Hello and welcome to the video 4.6 for Type 1, Type 2 reliability. Now these problems are technically Venn diagram problems, but I'm going to show you a method to use a diagram to help solve these a little better than the Venn diagram. Now these are problems could be dealing with percentages, or they could be dealing with numbers of things. Okay. This first problem is dealing with percentages. And what we're going to do is we're going to create a rectangular array with 4 boxes, and we're going to be comparing accuracy with not being accurate. Okay, so accurate, not accurate. That tilde means not. And in this case, we're dealing with a test to determine whether or not someone has a virus in the village. Now, in this case, let's read the problem first. Okay, so 80% of a village has a virus. The Red Cross comes in and administers a test that is 80% accurate on those who have the virus and 70% accurate on those who don't. Alright, so you have the conditions having a virus and being accurate. Those are your essentially two circles. So virus or no virus are the two possibilities for that event, and accurate and not accurate are the two possibilities for that event. Now it says 80% of the village has a virus, and I'm not giving any kind of numbers, so I'm just going to deal with percents. So at the end of each row, I'm going to write down the total, and the end of each column, bottom of each column, write down the total for those particular parts. If 80% have the virus, that means that 20% must not have the virus. Now we have to fill out this diagram. It's 80% accurate in those who had the virus. Okay, so of the 80%, it's 80% accurate on those who have them. So you're going to multiply that by 0.80. Doing that, we get 64. So 64% of the entire population, the test says accurately that they have the virus. Now you should be able to fill out the rest of that row because it has to total to 80%, so there has to be 16% remaining for those who had the virus, but the test was not accurate. Now the next part says it's 70% accurate on those who don't have the virus. So if I take those who don't have the virus, which is the 20%, and multiply it by the 0.70, that gives me 14. So 14% of the total population that don't have the virus have accurate results. And to fill out the diagram, to fill out that row, we have a total of 6% who don't have the virus and the test is not accurate. Now you have to be really careful what each little box and square represents in here. Okay. So let's go through each square. This first square with the 64 represents those who had the virus where the test said that they had the virus because it's accurate. The next box with the 16 represents those who had the virus, however the test was not accurate, so the test said that they did not have the virus. This 14 box, this spot represents those who don't have the virus, and the test says that they don't have the virus because it's accurate. And this 6 represents the percentage of people who don't have the virus, however the test said that they had the virus. Okay. That's what each box represents. So you have to be really careful about how you answer these questions. So, for instance, the probability that the test says that the person has the virus, the test says that the person has the virus. Not that they have the virus, but the test says that they have the virus. That's going to be the 64% where it was accurate for those who had the virus, plus the 6% where it's not accurate for those who don't have the virus. Because in this case, the test said that they had the virus. Out of a total of 100%, that gives you 70 over 100. So 0.7 is the probability that the test says the person has the virus. Now part B. Find the probability that the person has the virus given that the test says that they have it. Given. So that's conditional probability. So where does the test say that they have it? Well, it's at 64 and 6, which means out of 70. Now, out of that 70, where is it that the person actually has the virus? Well, the 64. So 64 out of 70. Calculate that by punching that in your calculator. 0.9142857143. So let's do nearest thousandths. 0.914. Alright, now letter C. Find the probability that the person does not have the virus, given that the test says they do have it. So given means we're dealing with another conditional probability. So we're still out of 70, because we're still dealing with given that the test says they have the virus. And where they don't have the virus would be that 6%. 6 divided by 70 is approximately 0.0857142857. So 0.086. Okay, so pause the video now. You may have to rewind just to look at this example one more time to see what was going on, but pause the video now, write down anything you need to. Alright, now let's look at, oops, okay. Something popped up. Alright, it's good now. So, this next example deals with numbers of people. So in this case, we have 250 people are randomly selected to take a polygraph test. The test is 85% accurate on those who tell the truth and 25% accurate on those who don't tell the truth. Only 210 people told the truth while taking the polygraph test. Alright, so again we have the events accurate. So we have accurate and not accurate. And we also have truth. They told the truth. Or they did not tell the truth. That looks a little better. Alright, now we're dealing with total numbers of people, so let's deal with the total of 250. So all these four boxes should add up to 250. It says only 210 people told the truth while taking the polygraph test, so the total of truth tellers is 210. Therefore, the total remaining that told anything other than the truth must be the remaining 40 of the 250. Now the test is 85% accurate on those who tell the truth. So of the 210, we want to find 85% of that 210. That gives us 178.5. Now, of course we can't have half a person, but we're talking about just probabilities. So I'm going to leave it as a decimal because that's going to be helpful to use as a representation as we calculate the various probabilities. Okay, so we're going to leave it as a decimal, 178.5. Now of the 210, that means we have 31.5 remaining. Subtract them, you get 31.5. Now the test is 25% accurate on those who don't tell the truth. So of the 40, I need to find 25%, which is going to be 10. So it's accurate for those who don't tell the truth for 10 of them, which means that 30% of those who didn't tell the truth, the test said that they told the truth. It wasn't accurate. Now you can add up all those four numbers inside the boxes to verify they add to 250, and they do. So let's look at some probabilities. For how many people did the polygraph correctly identify as not lying? Okay, correctly identify as not lying means that they told the truth and the test said that they were telling the truth, which is at 178.5. Now, in this particular case, we're asking for how many people, so we can't leave our answer as a decimal, so 179 people. Letter B, find the probability that a person was telling the truth given, so conditional, that the test says that they lied. So where in this diagram is the test telling them that they lied? Well, for those who tell the truth, it wasn't accurate. That's one place. And also, what they actually lied and it was accurate. That's what the test is. So the 31.5 plus the 10 is what we're going to be out of. 31.5 plus the 10. Now, of those values, where was the person actually telling the truth? Well, the 31.5. So we're going to calculate 31.5 divided by 41.5. That should be 0.75903614446. Going in this black area a lot today, aren't I? Alright, so 0.759. That's the probability that the person was telling the truth, given that the test said they lied. Alright, let's look at one more. Part C. Find the probability that the person was lying while the polygraph said that they were telling the truth. When you see the word while, that typically means a conjunction. So it's not a conditional probability, it's going to be a conjunction. So you're looking for the spot in the diagram where the person was lying and it was telling them that they told the truth, so it wasn't accurate. Okay. So they were lying and they weren't telling the truth, which is going to be 30. So 30 divided by 178.5. Divided by the total, which is 250. Oh, blast it all. I made a little boo-boo. And instead of having to re-record this video again, I'm going to just say this problem all over again. So let's look at part C again. Person was lying while they were telling the truth. That actually is conditional probability. Okay. Alright, so let's look at this. It's going to be while the polygraph said that they're telling the truth, which is the 178.5 added to the 30. And of there, the person was lying is the 30. So 30 out of 208.5 is approximately 0.143884891. Dot 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 dot. So 0.144. My apologies for that mistake. The language in these is a little tricky, but so as you're working on the assignment for this, just check the answers as you go along, and if you have something that differs from my answers, chances are that it's probably conditional if you didn't think it was, or isn't conditional if you thought it was. Okay. Alright, pause the video now, write down anything you need to before moving on. Alright, so in summation, okay, we had type 1, type 2 reliability. It's typically dealing with accurate results versus not accurate results. Okay, and we're going to be given another event, for instance, either having a virus or not a virus. We could have telling the truth, not telling the truth. Okay, and each box represents a certain thing. Okay, and you kind of have to be careful how you interpret those boxes. Alright, again, I apologize for that mistake in that last example, but hopefully you'll forgive me. Thank you.